Hi, I'm Brian Mullen, and this is Balls Out Physics, Episode 2, The Gravitational Constant. This episode is mainly about gravity. And so the bread and butter physics equation up here, one of the first equations you learn in Physics 1 is force is equal to mass times acceleration. This is what Newton based all of his three laws of motion on. And since his boy Copernicus, 150 years prior, had come up with the solar system, he knew that he needed to come up with an equation that would not only work on Earth, but would work throughout the universe. Okay? And so what this equation says is that the force acting on an object is equal to the mass of that object multiplied by the acceleration that the object is experiencing. Okay? And mass is defined as the amount of matter in an object. And in Physics 1, they hammer into your head that mass is the same throughout the universe. Only weight changes because the gravity on each planet can change. You know, the gravity on the moon is less than it is on Earth. It's supposed to be about 1/6 of what it is on Earth. And so I was taking physics, and I had just taken chemistry, or I was taking it at the same time, I can't remember, but I immediately thought about the fact in the lab we were weighing things in terms of grams. And in the metric system, grams and kilograms are actually units of mass. But to determine mass, we actually weigh it, or weigh an object, and we say this is how massive it is. And so I thought to myself, well, if that's the case, if I took that same scale up to the moon, it would definitely give me a different reading because the force of gravity is less, and that's what's pulling the scale down, right? So how can that be? How can mass be the same throughout the universe? Does that mean we would have to calibrate our scales to work on the moon so that they show the same mass that we get on the Earth? Or do we use a conversion factor instead? Or how does that work? Does that mean that just all mass in the universe is actually defined on Earth? I don't know. I never really got that, but at the time I had been in school for a long time. I was 18 years old and I was ready to get out and go make some money, so I didn't really ask too many questions. However, I always questioned that and I always thought about it, and I've talked about this with some other people, and there are a lot of people that say, yeah, that doesn't really make a whole lot of sense. But it's accepted in the physics world. How we determine the weight of that person, okay? Or the force of gravity acting on that person. Weight and the force of gravity are actually the same. Weight and the force of gravity are actually the same, or at least that's the accepted belief in physics. You know, weight is actually caused by the force of gravity of the Earth pulling down on the object, in this case, the person.